so I'm going to go through a homework question. This is from the Review and Consolidation 2 for Redox, and it's question 3 from the practice questions. I'm going to go through the last part of that, which asks you to find the percentage purity of copper in the brass. So here's a slightly shortened down version of the question, just so I can fit it on the board. And the first thing to do here is to draw a diagram of what's going on. That'll really help us process the question. It'll also massively help us spot if there's any samples or things like that. So I'm just following the Mesmer method. Now, as it's a thiosulfate question, we're going to need 2 equation steps, and we'll talk more about that later. So first thing I need to do is go through the question and make my diagram of what's going on. So it says we've got 2.56 grams of brass. So I'm going to write that down there, and we've reacted that with excess conc-nitric acid. And then it says that converts all of the copper to Cu2+. So we're making Cu2+ in that beaker. The solution is then neutralised, so what's that going to do? That's going to get rid of any excess nitric acid, because otherwise that might interfere later on with our reaction. So nothing mathsy to do there, we can just ignore the nitric acid from now on. And it's made up to 250 centimetres cubed. Now what you might want to do is straight away convert that to decimeters as well, so you don't forget later on. It then says a 25 centimetre cube sample, and this is still going to be the copper, isn't it? We've now made copper 2+, is pipetted out into a conical flask, and excess potassium iodide is added. So we've added some I- there. So we're going to get this reaction, we're going to be making I2. So this reaction there. The iodine formed is then titrated, so we've got our little burette with some thiosulfate, and it says we have a concentration of 0.1 moles per decimeter cubed, and our volume is 29.8 centimeters cubed. And then it gives you the equation for that as well. Although you'll never directly get asked about those equations, this one, I would actually try and remember it, because it crops up all the time, and if you're familiar with it, you'll just find the questions a lot more recognisable, and it won't stress you out as much, because you know, what the hell is this thing here? You'll just know it, so I would memorise that one. So this is our diagram. We've got all the information we need here. We don't actually really need the question anymore. All we need to do is look at our diagram. So we have now done our diagram step. We can cross that off. The next step is the N here. This is find the moles of something. Doesn't matter what, doesn't matter how, just get the moles of something. So we can see by looking in our burette here, we can find the moles of the thiosulfate. So we can do moles thiosulfate equals, and that's just going to be CV, so 0.1 times 0.0298, because don't forget that needs to be in decimeters, so 0.00298. We can then do our equation step, so we're going to convert our moles of thiosulfate in the titration to our moles of iodine, and we're just going to use this equation there. So our thiosulfate to iodine ratio is a 2 to 1. Therefore, our moles of iodine will be half the moles of the thiosulfate. So that will be 0.00149. But what we really want, we don't want our iodine, what we're asked about is the copper. So now we need to convert between the iodine to the copper. Now just one little thing here, although this iodine has a molar ratio of 1, and this iodine has a molar ratio of a half, these are the same amounts. You'll have the same number of moles of iodine here as you have there. Because look, the iodine we made in this reaction here, we titrated all of it against the thiosulfate. I didn't take out some of the iodine made here. I didn't add any more iodine here before I titrated it. So the rule is you can use the big numbers, the molar ratios, within an equation, but you cannot use the molar ratios between equations. So the fact that that's 1 and that's a half is irrelevant. Whatever your moles of iodine here is here, it is exactly your moles of iodine there. So the fact I've got 0.00149 here means I have 0.00149 there. So we can now convert to our second equation set and convert our moles of iodine here to our moles of copper. And it is a 0.5 to 1 ratio, or basically a 1 to 2 ratio. You'll have twice the moles of copper. So our moles of copper in here is going to be back to 0.00298. We don't care about the moles of copper in here though. We care about the moles of copper in our original solution. So we need to go back through here. Now, this is a sample that we've gone from a large volume to a smaller volume. So we need to find the sample factor. The sample factor is just big V over small v. So 250 over the 25, which equals 10. That tells you your bigger solution is 10 times as big, so you'll have 10 times as much stuff. So I need to take my moles of copper here, times it by 10, so my moles of copper in the original solution will be 0.0298. That's our sample done. And then we have this second moles equation, whereas the first moles equation always starts moles equals, the second moles equation will always start with whatever the question asks. Now the question was asking to find the percentage purity or percentage mass of your copper. Just going to get a little bit of space. Okay. So the equation for percentage purity or percentage mass is pure mass over impure mass times 100. So if the question's asking you to find the percentage mass, you're always going to be given the impure mass. Always. Look, it's here. It's giving you the impure mass. So what it's really asking, if it's asking for percentage purity or percentage mass, is it's asking, find the pure mass and then bang it in this equation. So this second moles equation here, we're going to find our mass. So our mass of copper is going to be moles times MR, so that's got AR, so that's going to be 0.0298 times 63.5. Definitely going to need my cheat sheet for that. So that's going to be 1.8923. We then just need to bang this mass in this equation here. So my pure mass, 1.8923 over my impure, which you're always told. So if it asks you to find the percentage purity or the percentage mass, and it hasn't given you the impure mass, look harder. It has done, you've missed it. Maybe it was on the previous page or something like that. Either which way, this question is 2.56 times it by 100 to get it as a percent, and you'll get 73.9%. Okay?